All right. I hope everybody had an opportunity to get your sugar or your caffeine or both. And for the rest of you, there's an apple back there so you can feel good and get a little healthy sugar. But if you all can grab a seat, we have two more sessions here. Happy to bring to you right now Eric and Stuart. Eric from Veolia is going to talk to you about wind repurposing, and Stuart's going to talk to you about the solar recycling world. So if you all can grab a seat, if you guys want to come on up, we'll go ahead and get this party started. Again, if you have questions online, please hit the chat button or the Q&A. We'll make sure we get those answered. The PowerPoints and presentations will be provided to you at a later date. Eric.
Everybody hear me? Eric Hagan, I'm the general manager for Veolia North America, overseeing the wind turbine blade recycling program. A little bit of background about Veolia. Veolia is a global company. It is a French company. In the United States and Canada, we have 64 facilities. We specialize in water, waste, and energy. Prior to 20, we had no experience in wind turbine blades of any sort of kind. General Electric approached Veolia as an environmental solutions company. If we had an alternative to processing and recycling wind turbine blades as opposed to landfilling, we had no idea what we were doing, but we knew that we could figure it out. So we got a team together and we thought about, well, what are we good at? We're good at providing fuel to cement kilns, to offset coal and natural gas, and how can we make this work? So that's kind of the path that we went down. We finalized a partnership with GE General Electric in May of 20. We started processing our first wind turbine blades in September 2020, and since then we have handled and processed over 3,900 wind turbine blades. Next slide. Next slide. So Veolia is processing the blades. We're recycling them as a use as a raw material and fuel replacement, using cement kilns as coal processing chemical technology, also using lime kilns as well. Basically, they're both kilns and use the same chemical process. And so this production aids in the cement industry. Cement has made basically a commitment to decarbonize by 2050, 80% by 2030. Some cement plants are well on their way to make that happen. Some have a lot of investment to do. We work with several cement plants, several different companies to aid them in making this possible. Some are has permitted, some are non-has permitted. The has permitted cement kilns will have to also use some non-has to make that 80% commitment by 2030. So next slide. So basically, a cement kiln needs certain chemical ingredients to make clinker, which then is ground in a ball mill or a roller press to make the cement. Some of the chemical components is silica, aluminum, iron, calcium, and then they need a fuel source. So what a wind turbine blade can do is it provides a raw material replacement for silica and calcium, and then also it does have a BTU value since it does contain wood, epoxies, some foam. So there are some BTU values associated with that. So one turbine blade can replace 5 tons of coal, 2.7 tons of silica, 1.9 tons of limestone, and then about 1% of other necessary ingredients. 65% of the wind turbine blade is used as a raw material replacement, and 28 to 30% as a fuel replacement, which helps offset the use of coal and natural gas. The raw material also helps a cement kiln by decreasing the mining needs for these raw materials. And that's it for me. Any questions?
Anybody here? Okay, good. All righty. My name is Stuart Bauer, and I'm from Missouri S&T, also formerly known as University of Missouri Rolla. And I teach in the architectural engineering program. Been there since 2002. Also been involved with the construction and design and construction of the several solar houses that we've done there. And lately, I've been looking at other renewable aspects of it, especially looking at the long-term effects of renewable energy. PV recycling is going to be one of the things that needs to be addressed nationally. Internationally, it's already being addressed in several parts of the world. Other parts are not. But obviously, with the new incentives that we have from the federal government level, the explosion of the PV industry is just going to keep increasing exponentially. And here are some facts to go with that. If you would, please, next slide. So here's some forecasts of U.S. solar PV deployments in the forecast there prior to a recent act that was passed. And you can see that the capacity will reach over 400,000 panels just in 2016, but beyond that, at 129 gigawatts today to 336 gigawatts by 2027. Okay, that seems reasonable. However, if we go to the next slide, thanks to the Inflation Reduction Act, that chart that you saw prior is not even reflecting this recent act that was passed, and thus increasing the number of solar panels out there, going from 10 years of 69% more solar deployment nationally. By 2032, the U.S. will have installed 682 gigawatts. Again, this is the current administration's desire to reach zero carbon footprint by 2050. An additional 222 gigawatts of solar over the next 10 years. Okay, that sounds great. However, it does present a problem. Like everything else, there's a limited lifespan behind solar panels. What are we going to do with those afterwards? You can give me the next slide. And just on a global scale, you can see where that is being projected worldwide. It is, a wonderful renewable source. However, it also has some impact, environmental impacts later on. If we go on to the next slide, I'm not going to even, okay, there you go, 62.1 gigawatts in 2018, 132.4 gigawatts by the end of 2023. That's only next year. Let's go on to the next slide, please. Installations worldwide. You can see by the color based on the parts of the world, the United States will increase their solar production by anywhere, from today at 2020 or 2022 to 2050 by a full 2%, 3% more than what we have projected here. Go on to the next slide. And with that, obviously, the decrease in cost of producing, thanks to the Swanson law, is actually dropping solar production and solar cost by 20%. And that is thanks to massive production of solar panels across seas, as well as even the technology and the means of reducing the type of resources that we've allocated for those things to generate even more efficient solar power and solar panels in this place. Okay, next slide. All right, and this is of course reaching parity across the nation. As far as when you look at utility costs, before parts of the country there was obviously fossil fuels was the way to generate power, and it still is in some parts. But yet the parity in the cost of producing solar power is becoming more competitive nationwide. And this is obviously going to add to the exponential growth of the solar panel and solar industry in this case. Let me go on to the next slide. right. So here are some of the challenges for us. Solar panels last about 20 years, 25 years. If we grow the industry from to about 4,800 gigawatts by 2050, which is approximately 1,000% increase in solar deployment, at some point in time, those panels will have to be decommissioned and moved on, and will be replaced with others. It's kind of like our cell phones. How many people hold on to their cell phones after 5 years? 10 years? 2 years? You start to see where the problem lies there. So at some point in time, we have to recycle these panels there. Go on to the next slide. There we go. So 25 to 30 years. In 2016, it was estimated that we had 250,000 metric tons of solar panels that was decommissioned and moved on. And unfortunately, nationwide, we really don't have a means to mandate recycling. Economically, it may be viable based on various types of economic trends. Obviously, there's various types of materials that can be recovered from solar panels there. If you go on to the next slide, I think I have a little bit more information about that. But here's the forecasted PV waste amount. Look at the projection for, obviously, China leads the charge, but the United States is right behind that. And this is going to, obviously, with the Inflation Reduction Act, may even expedite that process even more. 60 to 78 million tons of waste globally by 2050. Next slide, please. And what we're throwing away is basically some very good resources. I mean, these are natural resources like glass, silica, aluminum, and these are materials that can be easily recovered and recycled into the process. There are even some precious metals in there. On the older panels, you can find silver for the various kind of electrical conducting materials there. Now, I would tell you right now, if you're thinking about rushing out and opening up a company to recycle silver from these panels, you may want to hold off there, because over the years, silver itself has become such a precious metal that they've actually started to reduce that due to the increasing cost of producing these panels there. So again, kind of a way of trying to make it more competitive and price worthy. If you go on to the next slide. Obviously, other parts of the world have started to tackle this more and more. PV use in Europe, as you well know, with the energy crisis, is going to also exponentially grow, because that's what they're banking on. They're looking at solar power as one of their primary sources of renewable energy. And so in 2012, they actually have a program to try to help stimulate and move everybody into recycling those photovoltaic panels there. Next slide, please. In the case of the U.S., our recycling program is, based on the Federal Resource Conservation Act and Recovery Act. I'm sorry, and yet it is not required. It's not mandated, and obviously there are various types of parties and interest groups that are looking at trying to change that and trying to influence policymakers to change that aspect of it all. But as you can tell, several states have started to look at that more seriously, California being one of them, New York, Washington, and so on. Next slide, please. So in the case of recycling panels, as I mentioned, there is various types of movements going on in the private sector as well as in the public. As I mentioned, with some of the states, they are looking at forcing or adopting a legislation that says to the producers or to the manufacturers, if you manufacture or if you're a distributor of PV panels, you also have to put in a plan to recycle and recover those panels after use as part of their incentive package there. Obviously, that cost is being passed on to the consumer, but with the idea that eventually that some of that recovered material can be also helped to offset the cost production and plant reclamation of that process there. So if I can have the next slide, please. Here's several companies out there that have been recognized by SEI as a SEIA, excuse me, as a sustainable practice of PV recycling. And some of these have actually pretty interesting programs behind them. If you look at some of them, you'll find that they don't just take all the panels and just crush them and destroy them or try to recycle them. They will actually go through and test a series of panels to figure out if any of the panels still have some viable energy capabilities there. And therefore, they will actually package that as a secondary market for distribution in other areas there. But on the same token, the sustainable practices of trying to recycle panels, I have to warn you, there's a lot of companies out there that will try to say, oh, we'll recycle your panel, no problem. And they'll just take the aluminum off, they'll take the copper leads out, they will maybe remove the glass, but the actual silicone or monocrystalline silicone will actually be discarded. And that's where some of the problem lies, because there is some adhesives to go in there, there's some other chemicals to go in there that actually can create environmental hazards at the landfill site. You go on, please. And here's a kind of a quick diagram of what you can find in there. You have some, obviously, aluminum, some silicone wafer. There is obviously some silver in there too, which, and of course the glass. All these things can be recycled, and so it's something that I know the companies that I highlighted before obviously have a means to extract that. And there's really two processes that they typically use. One is after they strip the glass, they strip the aluminum away from the frame of the body, the silicone and the conductor materials in there are actually either chemically treated to separate those components from the adhesives that hold them together, or they actually put them in a kind of a furnace to kind of separate the material based on extraction from heat in this case. Both methods have their pros and cons. Obviously, the environmental impact when you're using chemicals, how do you discard those chemicals without causing harm to the environment? The other one, of course, is the off-gassing that goes with the furnace. Anytime you're burning various types of materials like this, there's some off-gassing that has to be addressed. If I can have the next slide. So, as in the case of the percentages that you see there, these are, again, some roundabout figures. Different manufacturers might give you some different results in this case, but the fact is that monocrystalline, polycrystalline, and thin film are the three most common type of PV panels out there right now. Next slide, please. So in the case of the U.S. market, you can see where all three films that I have up there and where they anticipate the exponential growth at this point. There's a lot that's going to happen, and this is only up to 2025. This will continue to grow. But then how does that, dictate into today's market? Those companies I highlighted before, if you go on to the next slide, I think I have that on there as well. Whoop. Okay. The amount of material that comes with those PV panels, notice that silver is way up there at 90 metric tons. Like I said, silver right now, if you look at the market price of it, very attractive. But there's been another report that came out that says, however, due to the price of silver being so high, they are actually looking at alternative materials to reduce the amount of silver in the future panels there. So it may not be if you're trying to project out as far as, economic recovery there, this may not be the right place there. So, however, if you're just basing it on silver, if you look at aluminum, I just happened to look at the price of aluminum recently. It was trading at $38.50, $3,850 per ton back in January or February, and yesterday I think it was $25.10. So it too has a fluctuation in the market value, but the fact is that there is some possible opportunities there for you. Take a look at the next slide. So here we are, US PV recycling. The market growth is 2030. We're looking at $450 million in raw material, and that's going to be growing to $15 billion by 2050. It might not be a good, a thing you want to ignore at this point. If I can have the next slide, please. The companies that I was highlighting before, this is where they're located in relationship to Missouri. So you might ask yourself, so why doesn't Missouri have a company in place? I can tell you that from what I've seen so far, it is still a kind of a unknowing factor. How much viability is there in recovering PV materials in there from an economic point of view? But obviously, you can see they're spread across the country. I anticipate this to grow and grow quite well there. So, next slide. So PV recycling, if I can get the bullet points there. And my aspect of it all, I'm looking at it from a education, which I'm trying to make the public aware. This is going to be a growing market, informed consumers, and obviously interested parties. Anything that I can help to instill the importance and significance of this, because honestly, I don't want to see any PV panels going to the landfill. I don't want to jeopardize our generations thereafter. So that's my presentation. Thank you.
Hey, thank you both very much. Eric, the first question I had for you was for solar panels, there was a degradation of output. Do you know the reason that we recycle the wind turbines? Or like,
The reason we recycle the wind turbines,
like when they're put out of service, what's the reason?
there's a 20-year life expectancy out of the wind turbines. The manufacturers are taking advantage of the tax cuts, and also they've built new, more efficient wind turbines. So they're trying to replace that and optimize their energy efficiency. So on average right now, it's 10-year replacement.
10 years, even though they have a 20-year lifespan.
Correct.
Okay. So the next question I had is, I know over the last decade, there's been the discussion of, why can't we manufacture blades here, considering we're so close to where they're putting them up? And a lot of the discussion has been transporting them has been an issue. How do they get from the wind farm to you?
Yeah, so most of it is over the road. These are, I'm sorry I didn't mention this. These are 7 to 11 ton blades each one. They're cut down into 20-foot sections, put on a flatbed, transported to us. We also do have a field service that we can do some other filleting and shredding in the field to optimize transportation to us for our finished processing in Louisiana, Missouri.
Okay, so none of them, you're in Louisiana, Missouri. So none of them come to you full. They're all chopped up in some fashion or form.
Correct.
All right, interesting. Those were the things that popped up when I heard your presentation. Are there any other questions? Yes, Tim.
With respect to the solar panels, is there a disposal fee that's charged? And what would that be, and how much of that cover? How much does that cover the reprocessing cost?
It's a very good question, and unfortunately, I cannot find any standard flat fee for that. It depends on the company itself. There was a company here, actually in St. Louis, that was looking at collecting solar panels, but they weren't willing to recycle them on site. They actually were working with another company elsewhere, and I hope I'm not divulging too much information, in Tulsa, Oklahoma, which then you would have to basically, in my case, if I'm living in Rolla, I would have to have them shipped to St. Louis. They would then charge me a fee to ship them over to Tulsa, which didn't seem to make any sense to me at all. And I thought, and I talked to the company, I said, or the representative, I said, don't you want to try to recycle them on site? He said there was too many regulations in there, and that was his crux there. Honestly, I think there was a lack of understanding of what's involved in doing this there. So,
Any other questions? All right, Eric, do you see any other end use outside of what you currently use for the repurposing? Or do you feel that that's,
Yeah, there are some other, I guess, companies out there. Some is for furniture. Some are trying to utilize the blades for city municipality furniture like benches, seats. There's polymerization possibilities. There was a company that was trying to do some plastic pellets. So there are end uses. Right now, the blades are coming down probably faster than what facilities can process. So we need sustainability and a way to keep up with the demand that the manufacturers are taking down, so they're not piling up in fields and such. So
great. Well, thank you both very much. Please join me in thanking Eric and Stuart for coming in today and sharing that